Hi, in this video, I'm going to share one of the projects that I've been working on, which is about training a machine learning model that can detect speed signs on the road. My name is Mohsani, and I'm one of the solutions engineers at Edge Impulse. So the reason for this project is that when I drive my car, sometimes I feel like I forget what the speed sign is on that road, and my car doesn't have this feature on it already. So I thought maybe I could build this project myself, and I could have a module that I could attach it to my dashboard and could tell me all the time what the speed sign is. Easy and simple. If you're experiencing the same problem, drop a comment and I'll be happy to get back to you. Just bear in mind that we have a very short time in this video, so just treat this as a tutorial and an experimental project. We're not going to have enough data or enough time to train and improve the accuracy of the model. But this is definitely possible on your own free time. So just treat this as an experimental project, and this project is a great way to learn all the features that the Edge Impulse platform has to offer, all the way from leveraging LLMs to label your data set, training different impulses. I'm going to show you how to build an object detection and also a classification model. And at the end, you're going to see how to optimize this and deploy it on the Edge device. Okay, now let's start building this exciting project together. So first head over to Edge Impulse Studio, and I made a new project for myself, speed sign detection. The first step is I'm going to select my target device. So this is going to run on OpenMV Camera H7. So hit save there. So this means that all I'm doing on the dashboard is going to be optimized towards this platform. So the first step of the project is a data set. So I need to have a data set. Obviously, there are a couple of ways you can do this. You could start collecting your own data, label it using some of our AI labeling tools, or use a public data set, or use some of the videos that you have, or you can find it online and upload it here and label them. So for this project, I'm going to use the road sign detection dataset from Kaggle. So this dataset is public, so I could use it, and it gives me 4 different classes: traffic light, stop sign, speed limit, and crosswalk. So obviously I don't need all these 4 classes. I only need the speed limits. The other thing is this only gives me a speed limits, and it doesn't tell me what is the speed limit. So that's another thing I need to do for my data set. So let's go ahead and download this data set. Now we can head over to data acquisition part and upload our data set. Okay, let's go ahead and select the folder we want to upload here. So this is the road sign detection folder. I'm going to select the whole folder here. Hit upload, and this is going to automatically now detect the format of the data set and automatically split it between testing and training. And for now, I'm going to keep them all in training because I'm going to do some pre-processing on them. So let's go ahead. Okay, this data set is now uploaded, and I can now see all my data here with all the bounding boxes that I want. So this is all good, and the only problem is it has a lot of other data that I don't need because I just want to do traffic speed sign detection with the speed sign in there, which this one obviously doesn't tell me. So we are going to use our new AI labeling tool here. So this tool allows you to get help from big AI models and label your dataset or tidy up your labeling. So I'm going to first select the ChatGPT 4 or image object detection model. So this is going to ask me what models, what bounding boxes I want to relabel. And I can see 4 different classes here, and speed limit has 700 data in there. So let me first get rid of all the other data. So I want to get rid of all the traffic lights, all the stop signs and crosswalks. So select all, edit labels, traffic light. So this means anything that we have traffic light, crosswalk, and a stop sign, it's going to just delete the labels if I leave it empty. Perfect. Now I only have one class of a speed limit. Now I can go to AI labeling and get help from these big AI models that are hard to run them locally. They normally run on the cloud, but I can get help to tidy up my data set and fix my labeling issues. So I'm going to select this ChatGPT 4o, and speed limit is the label that I want to adjust. And I'm going to basically what road, I'm going to change the prompt to say what road speed limit sign do you see in this image. This is basically just getting the cropped center of the image. Respond only with the speed limit numbers like 30 or 40, or if you're unsure, say unsure. Yeah. So that's the change we need to do there. And if I wanted to remove the bounding box, I could just say it, but for now, doesn't matter. I'm going to just leave it there. Okay, now that we have the prompt ready, I'm going to say label all my data. I could just say, add a tag here saying AI labeling is enabled, just in case if I wanted to add other data in here as well. So if I click label all data, it's going to start labeling all my data that has a speed limit tag on them. Okay, my labeling step using AI labeling is now completed, and I can now head over here to see my data. So all the data seems to be labeled. Let's have a look at some of them. This is now just been labeled by ChatGPT 4.0. And as you can see, let's look at some other classes. This is 80 miles an hour. All the data seems to be correct. 40 miles an hour. All the data seems to be correct. And let's see. Okay, so there is this, we have this data that we need to change the label for it quickly because let's see what it is. Yeah, it is actually 70 miles an hour. So I'm going to change this. It's very tiny. Uh, okay, but other than that, we have everything looking good. Obviously, these are, this data set, I don't know which country is it collected from, but so one issue that we have is not all our classes are representative. We need to try to make it a little bit more balanced. So as you can see, I have a lot of data for 80 and 40 and 100, not much data for other classes here. So I'm going to try to get rid of them because I don't want to have a class that doesn't have a lot of data in there. So I'll just delete all of these to start with. Okay. I want to just basically keep 3, 4 classes in here that they have most number of the data, just to make things easier, because I don't want to make this complicated because of the time to start adding more uh, data sets from other data sets, basically. So let's just get rid of anything that has little data in there. Um, yeah, so if I delete all of these, let's have a look at onshore data set. I could probably fix some of these. Okay, that's 40. Let me just change this quickly. I can't see that, honestly. I'm going to just delete this sample. And same as these ones, I'm just gonna get rid of them. Okay, we now have a data set of 1, 2, 3, 4, 5 different classes and some unlabeled samples. We need unlabeled samples because we want the model also to learn if you know, the normal background that doesn't have any sign in there. Yeah, we want the model to learn that as well. Okay, so we have the data set. I'm just now going to perform train test split, because I want to just keep some of my data untouched. So I can do a validation set on them. Okay, so some of my data moved to the test set now. Seems like I still have a good representation of the data, although some of them have very few data in there, but let's go ahead and see what happens. Okay, in this menu, I'm going to start designing my impulse. I'm going to select a little bit larger image size, 160, and just raw pre-processing. I don't want any pre-processing in here. One thing I forgot is we need to make sure we have the bounding box option selected here, object detection, in the project settings. Okay, oh, this got deleted. 160 by 160 image, and I'm going to select object detection here and save. Next stage is, I think grayscale will be enough for this, but we will see. Let's just generate some features. Okay, my training is now finished, and I've trained object detection. Unfortunately, we can see quite a poor performance here, and the reason is because of the data and the size of the images we had. But I don't want to increase the image size, because in that case, that's going to increase our inference timing. So I'm going to change my method. So I've been using object detection for this. As you can see, the model has to detect the location of the coordinates of the object and also the label for them. And it's quite tricky for the model to do that, especially when we want to run it on a small device. So I'm going to uh, simplify the problem a little bit, and basically just going to get rid of the location and just use a classification method to do this project. Cool. Now, because this is a object detection data set, I want to change this to classification. But to do that, I'm going to edit the labels of these individually and overwrite them with something slightly different. Okay, so that's good. Okay, cool. Let's just overwrite this last one as well. Okay. We now have 5 different classes with different labels, and I'm going to now change to classification, 1 label per item, and I want to come back here and look at my data to see if it all makes sense. Okay. Let's change it to grid view. Okay, this is, oh, background has got some weird elements in there. This should be, okay, let me just quickly tidy this up because this is going to ruin the training. Okay, I did some tidy up here and we ended up with now background, 100 signs, 40 signs, 80 signs, and 90 signs. So that's good. We can now finally go and make our impulse. So again, here I'm gonna go with 160 by 160 image size, and we'll now pick an image transfer learning block here, and this is going to now train to predict 5 different classes. So let's train and go to next stage, which is image pre-processing. So I'm going to pick grayscale here and generate some features. Okay, we can see the feature explorers. It is a difficult challenge because there is no consistent groups and clusters of the features we can see, but we're going to go ahead and try to do transfer learning here. I'm going to increase the cycle a bit to 60 and enable data augmentation as well. And let's just go ahead and train this. This is going to take a few minutes, so I'll pause the video. I actually forgot to do one step here, which is I need to split the training and testing data to have some data for the test as well. Okay, now I can go through these these steps again. Okay, my model is trained now, and I can see it's giving 73% accuracy on training set. And I can see the confusion metrics, and the best part is the inference time on this device is 315 millisecond, and the RAM usage and flash usage can be seen here. Now, I want to give this a go, so I'm going to go ahead and do some model testing. This is testing on the data that hasn't seen before. So I'm going to kick this off, give it a few minutes. So this is completely fresh data. Okay, our model testing is also finished, and I am getting 78% accuracy on the data that hasn't seen before. So this is great. We could have a look at some data. This is predicted, this is labeled, and we can see some of the data that went wrong. This is, 80 and predicted it to 90. It's probably, it's quite far, and our resolution is very low, and it doesn't allow that sort of accuracy here. So this is uncertain. Background. Yeah, all good. I can now go ahead and deploy this model to my device, which is OpenMV. We have huge variety of options here. I'm going to kick off the build. Okay, my model is ready now, and I can go and deploy it to my OpenMV. Okay, my deployment is ready, and I've downloaded the model here to my computer. And if I open it, I can see 3 different files. I'm going to copy these into the OpenMV volume that's created here. Okay, and I'm going to now back into the folder and going to open this file. Let's open MV Studio. I'm going to make sure my board is connected and hit the run. Let me open the serial terminal as well. Okay, prediction is happening. I'm going to now grab some of the pictures from here, from the test dataset, and see how are we performing on them. I'm actually going to do it in the other screen so we can still see this one. Let's keep this one here. Okay, if you can see it here, I'm just pointing the camera to an image that I opened in my desktop. And as you can see, the accuracy or the prediction for the 40 is just higher than much higher than others. So this is good. Let's try another one as well. Just 1 second. I'll grab an 80 sign now. Okay, now I'm going to try to point the camera to this 80 sign here and see what happens. Let's just make it a bit larger. Okay. Okay, the 81, the 41 is still giving some signals, but 80 sign is still highish. Yes, so that's obviously the training data was very limited, and it hasn't seen, the reflections and all sorts of things are different here. So it's understandable, but right now, as you can see, 80 sign is highish. So I'm going to do some modification to the code, and let's do some modification, and I'm gonna try to make it so it will just give me one value. That's the predicted value. So just 1 second. Okay, I've done some modification. I just introduced an if statement to say if this is higher than 0.3, then print the value of the speed. That's it. And this just makes it much easier to test. Okay, it's 40, it's solid. Now let's try 80. 80 and 90 is just kind of um, going in between them. Yeah, sometimes 80, sometimes 90. It's not, yeah, it doesn't have the greatest accuracy there. I can even now modify this code further because I have an LCD display on this OpenMV module, and I could even show the traffic signs that I detected on the LCD. So let's do the modification now. Okay, I'm first going to bring the display. It should go here. Then going to define the display. And this is basically the name of our pictures that we're going to save in the folders. So I've just prepared these traffic sign files in very small sizes, 128 by 128, to show on my LCD, OpenMV LCD. So we just need to make sure the file names are exactly the same as these ones, because in my code, I'm basically going to just add a JPEG tag on top of the whatever speed sign is, and just show that LCD that's right. So that's very simple. I am now going to make sure this is connected and try to run this and try to bring up an image and see if this works. I'll show you now in a second. I'm going to now test my model that I built in Edge Impulse Studio on this little camera. It is OpenMV camera, and I attached a LCD display on it, and it's a very low power small device. Obviously we could build models that can run on much larger devices like NVIDIA Jetson or Raspberry Pi with this high resolution camera, but the challenge is really to make them work on small devices like this one. So I have now programmed it, and I'm going to plug this in. It's low power, so I could just run it off a battery power bank like this. Okay, it starts booting up. Okay, I've programmed my model into this small camera, OpenMV camera, as we talked about it, and just connected it to a small power bank. Obviously this can run on battery, so it's very low power. And I've flashed this model into this, and I'm just going to open a few speed signs on my LCD, on my display, on my monitor, and see if this camera is going to detect or not. Let's start with the difficult one that we didn't have a lot of training data for it. 100, 80. I just need to point the camera. If I do it with an angle, that's what I realized, it doesn't know, because I've never shown this angle. Wait, it's still doing a good job. Yeah, you see it's getting confused when it has an angle, but yeah, like this, it's not too bad. Obviously it's going through the LCD that it never seen these sorts of images before, and the lighting in my room and everything, and also the original images haven't been taken on with this camera at all, so that all affects the prediction accuracy. Okay, so let's try another image. Let's give this a go. Gonna hold this straight on. Yeah, that's good. 40. Okay, let's try 90 miles an hour sign. Boom, that's good. This one worked well. So honestly, I think we just need a lot more data, more representative data, and we just need to improve the algorithm. So this was a very quick show. Hope you enjoyed it, and we'll see you next time. Thanks so much for watching this video, and I hope you enjoyed it. And I'm sure you're going to build your own cool idea and project using Edge Impulse. If you have any questions, make sure to drop a comment and I'll be happy to get back to you. Thank you.